another Network Plus practical lab. If you remember in the one that we did last week, we covered some different routing topics. We covered static routes, EIGRP, and RIP. Put out a question this week to see what topics some folks wanted to cover with this week's lab. And came back, people wanted to hear a little bit about layer 2 switching. So in today's lab, we're going to talk about VLANs, MAC addresses, and ARP. So before we hop into that, if this is your first time checking out the channel, please go ahead and hit that like, subscribe, and notification bell. I appreciate it. If you're coming back, great to see you here. Drop some comments since we're in a live stream, and I will answer your questions as they come up. So as I mentioned, wanted to talk about switching, and to kind of break that down for people who might not be familiar. Switching is really what we're doing at the layer 2 level as far as allowing different devices to communicate with each other. Now at the layer 3 level, we communicate via IP addresses. At the layer 2 level, we use something called MAC addresses. We're going to go a little bit into what constitutes MAC addresses and how we can look them up on the devices and kind of the different components of those. But it's just important to understand that that layer 2 communication does use MAC addresses. So the first topic that we were going to talk about today is VLANs. Now what VLANs allow us to do is take a broadcast domain, which is in essence an individual subnet. So if we were to take a little bit of a step back and think about the communication that happens at the layer 2 level, anything that is within an individual broadcast domain is able to communicate with each other. And so initially, when we had layer 2 devices or switches, really you could take any type of device and connect it all up to that switch, and they would all be part of one broadcast domain. They'd all be able to talk to each other. Well, that was great, but it didn't necessarily scale all that well for larger environments, or really if you wanted to have any type of segmentation for security purposes. So the ability to create what we call VLANs or virtual LANs was developed, and what this does is it allows us to create multiple virtual broadcast domains on an individual device. So if we take a look at this diagram here on the main page here, we have a switch that is actually broken up into two different VLANs. I have a VLAN ID of 1 and a VLAN ID of 2. And what that does is it creates two separate broadcast domains that reside on that one switch. So instead of it just being one overall broadcast domain, we now are able to segment it into two. And actually, we can actually go even further than that and segment it into even more VLANs, but just for the sake of simplification, we're going to keep it really simple here. So having those two different broadcast domains on there, segmented into different VLANs, allows all of those hosts within that VLAN to communicate with each other. So for instance, the hosts attached to port 4, port 2, and port 6 can all communicate with each other, but they can't talk with the other hosts that are in the other VLAN, VLAN 2. In order to do that, we would need to have some type of layer 3 routing between the two different VLANs. Now, another thing that we can do to scale this even further is we can use something called trunking, which allows us to connect multiple layer 2 devices with each other and allows us to have those VLANs exist on those different devices and communicate back and forth with each other across trunk links. So if we look at the right-hand side of this diagram, we have another switch that's on another floor in a building, and it too also has VLAN 1 and VLAN 2. When we create a trunk link between those two switches, we now allow all of the ports that are in VLAN 1 on the floor 2 switch to communicate with all of the other hosts that are in VLAN 1 on the floor 3 switch. And vice versa for VLAN 2, we can have all of those hosts communicate over to all of the other hosts that are in VLAN 2 on the floor 3 switch. So that is, in essence, what VLANs are at a very, very simple level, and understanding that we can use trunking to allow multiple devices to have that communication go back and forth over the same VLAN over multiple devices. So we're going to hop into Packet Tracer, and I'm going to set up a very, very simple configuration with a few different VLANs and kind of show you how that works as far as communication within each of those VLANs. And then we're going to do some stuff looking at the MAC addresses, and then we're going to talk a little bit about ARP. So let me move over into Packet Tracer real quick. Let's see. Okay, we got Packet Tracer there. Let me minimize this, and we are going to go over here. Okay, so in the past, when it has come to what we've done with Packet Tracer, we've used a few different switches here. We're going to go find those down here. In the past, I think we've used 2960s. We're actually going to use a layer 3 switch in this instance because of the fact that I want to do some ARP stuff later on, and that will come in handy. So we're going to do one switch and 4 different end devices. So we're going to go 4 different PCs. And we'll just do this. Now remember when we were talking before about the way that we connect these, since these aren't like devices, we're able to use straight through cables. So let us go and pick that. And we're just going to kind of go in order when we connect these here. Oh, didn't mean to hit that like that. And we'll connect that one to port number 2. And connect that over there. And connect this last one to port 4. So on the left-hand side here is going to be VLAN 10. On the right-hand side over here is going to be VLAN 20. But we're going to configure the IP addresses on these first. So if you remember, when we want to do any type of NIC configuration on these devices, we're going to go to the desktop and click on IP configuration. Let's go 192.168. We'll make this really simple. 10.2. And it will be a /24. And let's set that default gateway on this to 10.1. And we can close out of that. Okay, and this one we're going to do similar configuration. 192.168.10.3 /24, and the gateway is going to be .1. Okay, so those are going to be for our VLAN 10. We can close out of that. And then for VLAN 20, we will go over here, do the same thing. 192.168.20.2. This will be a /24 as well. 192.168.20.1, and I bet you can guess what we're going to do with this last one. It's going to be .3. All right. 192.168.20.3, and you know the deal. Here we go, 20.1. Okay. So that should be it. And just to show you that we don't have anything that will really work at the moment, if we were going to go, I could ping myself 192.168.20.3, and I don't have any interfaces up, so we're not going to get anywhere with any of that, right? Okay, so no joy there. So, okay, let's go and configure the switch. Now, the interesting thing when we're using this 3650, you would go and you'd want to log into this like we did with all the other Cisco devices, and we would go to the CLI, and you get this error message that says device must be powered on. So it's kind of weird. I don't know why Packet Tracer does it this way. What you have to do is take this little power supply down here, drag it over, plug it in. Really, really weird. We could go dual power supplies if we were, really trying to do what we would do in an operational environment, but in this case, we don't need to do that. So, and as you see, as soon as I dropped that power supply in, then all of it started to light up. We do not want to do the system dialog. No. Press return. Okay. So let's see. What we want to do is configure the interfaces for the VLANs that we were going to use. So I'm going to show you a pretty neat command here. So sometimes in environments we have to do multiple or the same group of commands across different interfaces or groups of interfaces, and it can be a pain in the butt to go to each individual interface and do the same commands. So what you can do, interface range gi10/2, right? So those are going to be the first two ports. Switch port mode access, switch port access VLAN 10. So I didn't have VLAN 10 created, but since I put that command in, it then created it. And we can then do the same for the other group of ports, which are going to be for VLAN 20. So we go 3 through 4. I'm going to up arrow to switch port mode access. And then we're going to go VLAN 20. Now, for good housekeeping, we could go VLAN 10 name, whatever we want to do, engineering. And we go VLAN 20 name accounting. Sweet. Okay. So let's exit out of this and take a look at a couple things real quick. So we can take a look at our interfaces and see how they're configured. Show interface status. And what we see with this is we have the first 4 ports. We see that they are up and connected. We can also see that if we go over here and look and see that the green arrows are there now. So that's a good thing. And then we can see the specific VLANs that they're assigned to. So that's a really, really helpful command to use when you want to get a quick update on the status of your interfaces. So let's get out of that. And then show VLAN brief. This is also good as well. We can see all the different VLANs that we have on the switch. We see that by default, all of the VLANs on the switch are in VLAN 1. I'm just going to say this right now, just so you know, don't ever use VLAN 1 for anything. It is very, very bad practice. You want to use different types of VLANs, because what happens is if you stick with the VLAN 1 that's also used for kind of traffic or network management traffic within the switch, and then also it opens yourself up, I would say kind of from a security perspective, it's not all that great because of the fact that it's default. You can have people plug stuff in and has the possibility of people being able to get to places where they shouldn't. So you definitely want to change all of this. If this was a real switch, I would create an unused VLAN or a dead VLAN, and I would put all of my ports into that VLAN so that nothing is using VLAN 1. I'm trying to think anything else I want to cover on this. So we have the VLANs there, VLAN 10, VLAN 20. We have the switch ports up and connected. So now, at this point, I should be able to ping each of the hosts within each VLAN, should be able to ping each other, but they shouldn't be able to ping the hosts in the different VLANs, right? Because remember, I said that the VLANs, in essence, are associated with individual broadcast domains. And unless we have a layer 3 device in between those broadcast domains, only devices within each individual VLAN can talk to each other. So let's go and show how that works. So if we're going to go back to the command prompt here, and let's go 192, let's go ping 192.168.10.2. So it's pinging itself. And let's ping the other host in that VLAN, right? So that's good. If we try to ping .1, we haven't configured it anywhere yet, so that won't work. And then if we try and ping the other hosts, right? 20.2, there's no layer 3 device there, there's no router there to allow this communication to happen. So we will just do this just to prove that out. And again, if we go over to the other VLAN, we can do the same thing. And we can show that within VLAN 20, 192.168.20.2, they can ping themselves. They can ping the other host in the VLAN, but they cannot ping the other host in VLAN 10. Nothing there. And if we do that, nothing there. Great. So that kind of shows the segmentation that you can do with the VLANs. Now, we also talked about we wanted to take a look at MAC addresses, right? And how that communication happens from a layer 2 perspective. So let's go back in the switch and take a look and see what we can see from a MAC address perspective. So the way that the MAC addresses work on these different networking devices is that as soon as it sees any traffic coming in a port, it will learn the source MAC address that's coming in, and then it will write it to what's known as a MAC address table. So once it has that information for all of the different MAC addresses of the devices that are sending traffic through the switch, then whenever there's any type of traffic that's destined to a particular MAC address, it has this table that already has all of the particular interfaces and the MAC addresses that are associated with them. So if we go and we look at show MAC address table, you can see here that we have all of the different MAC addresses for the different hosts. So that's really kind of how that works from a switching perspective. You'll see that the type here is dynamic, meaning that it learned the MAC address by the traffic actually going through the device. You can also statically set MAC addresses if you wanted to. I don't really run into that as being something that I do in an operational environment very often. Another thing that's kind of interesting with this is it kind of starts to go down the road of what we can do with port security, where we can dynamically learn the MAC addresses that are coming in over a port and then lock that port down to only allow that particular MAC address to send traffic or source traffic from that interface, which is a pretty good security tool that we have in our bag for locking things down a little bit. So I'm trying to think if there's anything else from a MAC address perspective that we wanted to talk about. MAC addresses are kind of interesting. So it is 6 different bytes address in hexadecimal form. The interesting thing is the first 3 bytes of the address are actually specific to the vendor or manufacturer of the network interface card. So you can actually do different types of lookups on the MAC addresses to figure out like what the vendor is of the particular NIC. And then the last, the other 3 bytes, I should say, the last 3 bytes, is a unique identifier that is created by the vendor when they make the NIC. There are different ways that you can actually use software to change your MAC addresses and stuff like that, but that's something that is a little bit more outside of the scope of what we're talking about today. Let me look at my notes real quick and see if there was anything else that I wanted to hit on for the MAC addresses. I don't think so. I think that was pretty much what we wanted to do there. So the last thing that we want to talk about is ARP, or the Address Resolution Protocol. And what that is a way that's used to determine what the MAC address is of a particular host if you only know the IP address. And this is something that's used constantly on any type of communication that happens within a network. It's one of the fundamental protocols that's used. It's actually used at the layer 2 level. And it's what, in essence, makes it so that we can get traffic from one network to another. So I'm going to switch over to my browser real quick, and we will take a little look at a quick scenario as far as how ARP works, and then come back in here and configure the switch with a layer 3 IP address for the different VLANs, and then I'll be able to show you kind of some of the ARP information that we can get from that. So let us go and switch over to the browser. Let me bring that up. go back to Safari. Bring this up here. Okay. So this is from a Juniper webpage talking about understanding how ARP works. And so in this diagram here, we have host 1 who wants to send traffic to host 2. Host 1 is on a completely different subnet or VLAN or broadcast domain. All of those are kind of interchangeable in what we're talking about here, than what host 2 is. So it has a default gateway or a route statement within host 1 that says if something isn't on its local subnet, send all traffic to its default gateway. All right. So let's say it doesn't know what its default gateway's MAC address is. So in order to send that traffic locally on the subnet, because remember, if you're talking about communication within the subnet or within the VLAN or within the broadcast domain, that's actually going to happen at the layer 2 level. So it needs the MAC address to be able to send there. So if we see the first step here is that host 1 broadcasts an ARP request to all of the devices that are on its subnet. So it sends that out looking for a query, an ARP query, looking for the MAC address associated with the IP address of router 1. And the reason why we need the IP address for router 1, as I mentioned, is because the host that it's trying to get to is on a different subnet. So it needs to hit its default gateway to send that traffic there to get it to the next network. Right? So all of the devices on the subnet compare their IP address to the IP address that is in the ARP request, or the ARP query. And then router 1, since it has one that matches the IP address, sends an ARP response back to host 1 with its MAC address. So you see that it sends it back. From here, this is step 3, sends the MAC address back to the host. The host then transmits the IP packet to the layer 3 destination, host 2, using the router's MAC address, right? So it's going to send the traffic at a layer 2 perspective back to the router's MAC address, knowing that the router will then look at the IP information in the packet to send it on to the proper IP address. So then router 1 forwards the IP packet, forwards that IP packet to host 2. Kind of another situation here is if router 1 doesn't have the MAC address for host 2, it can then actually perform a ARP request on this particular subnet, on subnet 2, to find out where the MAC address is for host 2. So that, at a very simple high level, is how ARP works and why we need ARP when we're sending traffic from one subnet to another. So if we go back into the lab here, and let me switch back over to Packet Tracer. Okay, so let's go in here and create some layer 3 interfaces. Now, when we're dealing with layer 3 switches, one of the things that we do need to do if we are going to be assigning IP addresses to do routing is we need to turn routing on the switch. So we go IP routing, and then we're going to go interface VLAN 10. And we see that it changed, just by doing that, it changed interface 10 as to up. And we're going to go IP address. Now remember, we set these gateways before, 192.168.10.1. 255, 255, 255.0. And then we go interface VLAN 20. And we're going to go IP address 192.168.20.1, 255, 255, 255.0. Okay. Now we should be able to go and take a look at these interfaces. See that they're up with show IP interface brief. And what this command does is it shows you any IP addresses that are assigned to any interfaces on the device. And we see that we do have these up. We can do some pinging here if we wanted to. 192.168.10.2. So we can reach those. Right, and we can do 20.2, and 20.3. Now, another interesting thing that we can do at this point is, because we have a router on each of these different subnets, we should be able to communicate with each other. So if we actually go show IP route, we see that from a routing table perspective, we actually have two different /24 networks in the routing table, and we see that they're associated with these particular VLANs. So if we go back to this host, remember before we couldn't ping anything in the other subnets. Well, now we can. Now this isn't great from a security perspective, because that means that these two VLANs can now communicate completely open with each other. But we would normally do this on a device where we would have some type of security controls or ACLs that we'd put in place between the different VLANs. So maybe we would do the routing on a firewall and then implement some rules to not allow communication back and forth between these. But this would be the first step as far as setting up the routing to make sure that it does in fact work. So that is good there. And let's go and do this over here. We can ping back into the other VLAN, 192.168. And there is a reason I'm doing this, because I want to get the ARP traffic set up within the switch so that we'll be able to show it. So we're going to go 10.2 and 3, and that works and is awesome. And then we're going to do the same thing on this guy. Let's go ping 92.168 10.2. And let's go 10.3. All right. So let's go back in the switch. Now, if we want to see the ARP table, which is going to be a combination of the MAC address and the particular IP address that's associated with this, show IP ARP. And there we go. So we have all of our addresses. We have an age timer here. So eventually these will time out. So if it doesn't have this information, then it's going to have to go through the whole ARP process again. But while it has this information, it doesn't necessarily need to continue to go through that process every time it's trying to send traffic to one of those MAC addresses. Something interesting to note here when doing this command, though, is you see how there's kind of like this hyphen. Anytime you see a hyphen associated with an IP address and a MAC address in here, what that means is that this is actually on the device itself. So this is an IP address, a MAC address that is actually on the switch. And then we also see the particular VLANs that are associated with all of the different MAC addresses and IP addresses. Let me just double check my notes and see if there's anything else that I kind of wanted to hit there. I think that was pretty much it. So we covered VLANs, we talked a little bit about MAC addresses, we went over the process for ARP, and we went over looking at the ARP table as far as seeing the data that's in here. These are useful commands. The show MAC address table and the show IP ARP table are useful when troubleshooting. So if you're trying to see if communication is happening back and forth between devices, it's always good to look at the show MAC address table command on a switch. The show IP ARP command is only going to be applicable on devices that are actually acting as the layer 3 device or router for the particular VLAN. So if, let's say, we weren't doing the routing on this device and the routing was happening on another device, doing the show IP ARP here would not give you any type of results, right? So just something to keep in mind when you go to use either of those two commands for troubleshooting purposes. If nobody has any questions, then I think that will wrap it up. Again, I appreciate you guys checking out the video. Again, smash that subscribe and notification bell. I appreciate that. I'm going to drop some videos either here or over here. I'm not sure which way I'm facing at the moment. for some of the other Network Plus videos that you might be interested in. Drop a comment down below on any other Network Plus topics that you'd be interested in having a practical lab for. I'm going to throw out some more options out on Twitter. Out on Twitter to have people vote on what they would like to see next. So yeah, appreciate it. Go get at it. Keep learning all this awesome stuff. Take care, and we will talk soon. All right, bye.